Okay, so welcome to the second ADD workshop. The first one we talked about what is parametric modeling, what is a node, how do we link loads. We talked about data, flow of data always flows from left to right. And we basically developed an understanding of how to develop scripts and geometries based on those scripts, okay? So you should all have a very good understanding of how to develop a script, right? You're still learning different applications and different possibilities, that's fine, but you know how to develop the script and work through the data, right? So for today's session, I want to talk about plugins for Rhino, okay? Sorry, plugins for Grasshopper. So if we go here, foods for Rhino. Last week we worked with the native components to Grasshopper, right? So vanilla Grasshopper. This week we're going to be expanding on that. So Grasshopper can have a lot more interesting nodes, right? And all these nodes are based on things people have developed, right? So it's a community where people develop packages of scripts, and they put them on websites such as this one here, right? So it's called Fruits for Rhino. So with Fruits for Rhino, they have plugins for Rhino and plugins for Grasshopper, by the way, so you can also expand Rhino commands, right? But the Grasshopper apps, they're usually named after insects and organisms, so you have pufferfish and you have all these different animals, right? Today we're going to be working with probably the most used Grasshopper plugin. It's called Ladybug, okay? A Ladybug is very, very cool, right? Because it's a very flexible tool that helps you do a lot of analysis related to the environment, okay? So there's Ladybug Tools, which is a package of different families of components. And within Ladybug Tools, you have Ladybug, which is a package. You have Butterfly, it's another package. You have Honeybee, which is another package. Thank you very much. And all these packages do different things, right? So today we're going to be focusing on Ladybug. And Ladybug is mostly related to environmental analysis, okay? Butterfly, Honeybee, they're related to wind analysis and building use analysis. But today we're focusing on Ladybug. If you have a good understanding of Ladybug, the rest become kind of easier to follow, right? Okay, so plugins are things you can download through Fruits for Rhino. You have to create an account, and then you search for them like this. Usually they have different versions. Make sure the version you're downloading is suitable for your Rhino. Of course, you have to have an account, and then you download it from here. And usually you'll have instructions within the file you downloaded, right? And that gives you an overview over here. Okay. So, I mentioned the different families, right? So honeybee, butterfly, ladybug. And they use third-party software and environmental data to enable further functions in Grasshopper, right? So Grasshopper itself doesn't have anything related to environments embedded within it. But Ladybug allows us to access data related to the environment, okay? So we can understand in a specific context what are the different conditions that we can work with, right? So if you're doing any kind of environmental analysis, Ladybug is probably the best tool you can use. I mentioned earlier, it's a very cool tool because it's a very flexible tool. It allows you to do different types of analysis. But it's not like other packages of software. So if I was to compare it with the workflow of Green Building Studio on Revit, you upload a model and you get output. This one you have a lot more control over, right? So you can actually use the data to generate stuff rather than just stop at, here's my thing, analyze it, okay? So you can bring it in early in the process, right? So and that's what we're going to be talking about today. I mentioned that Ladybug allows us to access environmental data. So this is done using a EPW file, Easy Plot Weather Map, okay? And this is basically a data set related to the environment that we access through Ladybug. So every Ladybug script will probably work through an EPW. I'll show you how to download this in a minute. But this is Grasshopper. through the data, then you can do weather analysis, you can do sunlight analysis, you can do other types of analysis. Okay? Without the data, you can't really do that. I'm also going to be, if we have time at the end, showing you how to link different plugins together, right? So the powerful thing about Grasshopper is a very flexible software, right? You don't just have to work within certain boundaries, you develop your own tools, right? So you can actually bring in multiple plugins and use them together, right? If you understand the data flow, you understand how to use different information to drive different things, basically your possibilities are endless, okay? You can develop your own pieces of software, okay? Or tools, let's call them design tools rather than software. Galapagos is something similar, so it's based on an evolutionary algorithm. So Galapagos helps us iterate through, based on certain boundaries we define, iterate through multiple iterations, okay? So if we set some limits in terms of maximum and minimum for a certain geometry, we can iterate that using Galapagos. I'll show you more in detail later on. But again, it's based on evolution. So changing parameters means you're mutating. So the parallel will be mutating genes. Mutating genes, you'll get different outcomes. And then you have a pool of different possibilities, right? So Galapagos helps you iterate through those, okay? And this is the interface. Again, we'll go through that later. This is what I mean by combining plugins, right? So if we have a system where we can analyze, let's say, radiation or sunlight as a condition that we want to include in our design process, and we have another tool, so this is Ladybug, we have another tool that helps us iterate through all the different possibilities, then we can iterate through all the different possibilities using an input, which is environmental conditions, okay? So Galapagos is based on a score system, so if you link the outcomes of your analysis to input into an evolutionary algorithm, then you can combine them, okay? A lot of this might sound random, right? But when we get into the tutorial, it will make sense. So you install it through Fruit for Rhino, you create an account, you download it. Usually, it asks you to install it in this way, which is you take certain objects, you can place it onto the canvas. All of you have it installed now on the university computers, so you don't have to do this, but it's very easy to install, right? There's also third-party software that you might have to install, but usually when you download something from Fruit or Rhino, you install it in this way. You just drag it onto the canvas. Okay, so we need to get started. So I want you all to open Grasshopper and go onto the Ladybug tab on the top. So it'll be called Ladybug, or it'll be called LB, short for Ladybug, okay? And you'll get a lot of different components, right? Like this, show at the top. Go here. Okay. All right, so the first thing to do, again, go on Ladybug, and then just literally the first one, bring it onto your canvas, right? So click on the icon, and then click on the canvas, it'll show up. If you didn't attend the last Grasshopper workshop, try to follow along. Nicholas can help you a bit, right? But I think this is recorded, right? So you can see it later on, right? So, okay.
If you need help, just raise your hand.
Yeah. And if you have any general questions, ask me. If you need any help with something specific, ask Nicholas. Okay. And then we want the other one just underneath it. It's called LB EPW map. Yeah? Ladybug EPW map. Okay. So if we hover over this, it says set to true to open EPW map to a supported browser. Okay. Any idea what we're going to try to do now? Sorry? Locate the site. So what do we do here for this component? Give it a true command, right? So notice here, the octagon has an X in it, okay? So we're used to Booleans being, and this is something you'll learn more and more by using it. We're used to Booleans being this, right? Yeah? So this is a Boolean container. Oh, okay. So here they have it as an A. But you can also you can also have a text, right? So if I have a panel, I have a panel here, this is okay, and set to true, and I have a Boolean here, Boolean toggle, and this set to true. These are two the same inputs, right? Okay. So true here is literally the word true as a data type. Okay. So once you connect it over here, you should get a Chrome page open up like this straight away, right? So that node initiates or opens a website for you directly. Okay. So it's actually outside the Rhino environment. Okay. So here, Boolean toggle. So Boolean toggle helps us change from true and false. Okay. If I set this to true, you'll have the Chrome open straight away. Okay. So so these are all the different environmental data packages across the world that you can literally import into your environment, right? Let's say we're working in Manchester, so let me find the one in Manchester. Okay, zoom in, find the closest one to Manchester, okay? And I want you to copy the URL. So if you zoom in, not Russia. So it should be this one here, right in the center, right? Just copy the URL, okay? Yeah. You can choose anywhere else. Have we all copied the URL? Okay. So now let's go back to our environment. So now we have the link to the data that we want to use. Okay. Open up a panel. Again, we said the panel we can use to read outputs or create inputs. Paste it in there. Don't have a space after your URL. Yeah. Just make sure there's no spaces. Click outside and then connect. So the function of this node is to open our map for us to get the link. The function of this node is to actually download the file using the link. So once I link this, my file is actually the data type file is already downloaded on my computer, right? So this is my link. I connect it to the URL. And then if you create a panel, so you can see here, it gives you the location of the file. Okay. Is that clear? We're only 2 nodes in. So one node opens the map, copy the link. The other node downloads the file based on the link we copied. Okay. Okay. So the next node I want you to use is called import EPW. Okay. By the way, all this stuff you actually will find online very easily, just because I've done it so many times and I know which nodes to use. Right? But if you're ever in doubt, just have a look online. You'll find these. This is a typical way of setting up the script.
Where do I get the link for the
So if you use this, it opens up this opens up the link for you.
Right.
Then you copy the link.
Yeah.
Then you bring it back in. Okay?
Okay, cool. Thank you.
Okay, so I want you to connect this, right? The EPW file to EPW file. We can see some of the conventions now appearing in Ladybug. Right, so Ladybug conveniently has the names of the outputs similar or identical to the names of the inputs, right? So connected, and now I want you to just take a panel like this and try to understand what each of these mean. Okay. It's not showing the. Anyway, okay. So just briefly, so this is our EPW file, and basically this node helps us isolate all the different data we have around the sites. Okay. So we have the dry bulb temperature. So these are related to temperature. We have humidity. We have wind speed. We have wind direction. We have direct normal radiation. So this means sun rays, right? So all these different outputs are actually specific to Manchester and the environmental conditions in Manchester. So all we've done now is actually just import the data we need to work with. Any questions? No? Okay.
Why were you using TMY?
Sorry?
Why were you using TMY data instead of IWPC?
But use EPWC. EPW. The EPW, yeah.
But why?
Because this is the data set that the whole plugin is designed around. Okay? So you can see here, it doesn't say import CSV or import HTML. It says EPW.
Yeah, but I mean, so
There's other data types available on the web. Ignore those. Look at EPW.
right. Okay, well, yeah.
I don't know. I haven't actually played with them, so I don't know if you can actually use it. Okay. So, okay. So, how do you think you actually develop nodes like this? How does someone, let's say you want to develop a plugin. Okay? How do you develop it? How do you develop just this? Right? Forget about the plugin. How do you develop just this? Script. Okay. Script in which language do you know? Sometimes in Python, sometimes JavaScript, sometimes
C++.
not JavaScript, sometimes C Sharp, sometimes Visual Basic, right? So all what we're engaging with is visual programming, right? So this is what we talked about last week. But all this is based on syntax, right? Text syntax. So if we have a let's say a random plugin in Grasshopper, we can't really peek in, okay? Because this is packaged and closed. But if you really want to freak out and you get bored like I do sometimes, I want you to double click on Ladybug plugins. Okay? Because you'll find all the scripts involved in developing these plugins. Okay? So again, it's supposed to be a very open community, right? And this is not on purpose. It's because people are expected to look through this and develop it and contribute back, right? And actually, they have online forums that you can ask questions and they will answer to it. So none of this is magic. It's just a lot of person hours of someone spending their evenings installing all this kind of stuff. Okay, so you can see here it's developed in the Python programming language. Because this is a Python code, we can open it. So other nodes we can't necessarily open because they're developed in C#.
We can change that.
You can change it. If you change it, you probably crash the plugin. But if you add something useful and then propose it back to the community, they'll involve it in the suite. Right? So it's supposed to be open source. Okay? This is what open source is, for everyone to develop it together. Yeah. So yeah, if you're ever bored, you can try to read through, right? Syntax is very different to what we do in Grasshopper, right? So you have all this green really doesn't do anything because it's based on a string. Right? But anyway. Just something to be aware of. None of this is magic. This actually has a lot of work put in, right? Yeah? Lost the screen. And in CPU, especially in 6th year, 5th year, you're working, right? Yeah? Especially in 6th year, we're going to teach you how to develop syntax like this, right? So Sol and I will teach you how to develop stuff in C#, not C#, JavaScript and Python and C#. Yeah. So why do we work in Grasshopper and we don't work here at the moment? Because we have everything we need in Grasshopper, right? But once you reach a certain stage and you want to do something that it's not very easy to do in Grasshopper, it's actually easier to do in this, despite this looking very intimidating. Okay. Getting notes, but take it from. It's just a blank. You have to blank again.
Every single time.
Yeah, from here. Cool. Okay. So now we've imported all this, right? So what I want to show you now is what we're going to be developing, right? So now we've downloaded the data. We have it in here. By the way, this is what we have. This is where we are. Right? This is where we are. So if I show you this quickly, we can see that there's some kind of reading, right? So this is basically direct sun hours, right? So by linking the environmental analysis, which is here based on sun path and based on direct sun hours, linking this to Galapagos as a way for me to iterate different options. I'm just going to show you very quickly. Again, I did this last night, so that's what I do when I get bored. We can start taking that information from Ladybug and having it as inputs into our different ways of I think slowly. Okay, and having it as an input for our massing, right? So if we try to understand the different conditions based on light, how do we maximize or minimize it based on different geometries? Okay? So this is what I mean by getting a score here in the shape of direct sun hours, and then linking it back to something we can iterate. Okay? So this is to show you where we want to be at the end. So you know roughly where, how we're working around here. Okay? Sorry? Yeah. Yeah. Yes. Huh? I want to show you everything. Don't worry about it.
Problem with the monitor.
Okay. Yeah. Do you have any? Okay. So this is why we're importing the data, right? We're importing the data to help us analyze different options. Okay. So let's go back and start now. So the best thing I find, the best piece of advice I can give you with working with Ladybug, is to start off with this, set up your data, and the end bits, which is what kind of analysis you want to do, right? So if we go here on Ladybug, you'll find that so this one is about importing data. This tab is about analyzing data. This is not related to geometry. This is visualizing. Again, we can see here sun path is one, so we actually need that. I'm going to bring that in. Sun path. And these are different ways we can visualize the data as well, right? For us, we're going to be working with direct sun hours today, right? Radiation is another one. Anyone know the difference between sun hours and radiation? Hand up. No? What is radiation? Huh? Yes, exactly. So radiation is related to the energy, right? So we can have direct sunlight in the morning. It's less hot in the afternoon. There's more radiation. Right? So it's related to the intensity of heat. Okay? So so you can do one related to views, visibility. So this is what I mean by starting off with where you want to get and then working backwards, right? So for us, we're going to work with sun hours, right? So I'll bring that in as well. Okay. So you should all have, and you can see some of these nodes are getting really big, okay? Sun path and direct sun hours, okay? Just get those in first and then we can start working. Okay. So, because Ladybug is developed outside a Grasshopper environment, you have some peculiarities that sometimes are different. Okay, so what you'll find is the way they name inputs and outputs is slightly different. Okay, because they have underscores at seemingly random locations. You see them here? But these are not random. Okay? So underscore on the left means it's a necessary input. Okay? So for every node, you don't have to connect all the inputs. Okay? But if it has a left underscore, it's necessary. Right? We can't do any sum path analysis without knowing where the location is. Is it in Manchester or Rio de Janeiro? Okay? So that's important. North, it assumes that it's Rhino and direct, right? But if you change it to cap. So right means input is optional. Okay? Left is needed, right is optional. And you'll find vectors and vectors. Again, the names are almost always identical. Okay? So if you know this, you can easily start understanding what you need to connect rather than looking at all these inputs and saying what's happening. Right? Like 15. Where am I going to find all these 15 inputs? Okay. No. It's just a naming convention to make things easier. Right? So if this didn't have this, there's no way to signify its importance or necessary. Okay? It will give you an error here, right? So here we talked about the bubble at the top. So if we go here, you'll see input parameter underscore location failed. So this one has both, right? So this is also optional. It has both is optional. It has one on the left is necessary. Okay? So you can see this is the only one that's necessary, and it's got picked up as a warning. There's a slight difference between this and this. So what's this? I think this is optional, but more important than this. Okay? It's the way they name it. Okay? It's supposed to be helpful, though, so don't try to. Yeah, I don't want to confuse you. That's it. Okay, so first thing, we have the data. We want to do sum path. Sum path is asking me for location. My data has location, so location to location. Okay? Straightforward. So, it's changed from orange to our typical gray, right? Not the light gray. So it means it's running, okay? So we actually have an outcome already, by the way. If you go on your Rhino environment, you would see a sum path diagram. Yeah? So you go here, you see a sum path diagram. Okay? The sum path diagram will always start in 0, 0, 0. Okay? So, I see a lot of you go on Illustrator spending half a day making a sum path diagram that's actually not very accurate. Okay? You can do it here in 2 seconds. Okay? So here, the center, again, so if you hover over where it says center points, it says here default 0, 0, 0, right? And that's the location of the sum path. Okay? So we can actually change this. It says center point, a point for the center of the sum path. So if we have a point in our environment, we can move this around. Okay? So type in PT for points, this one. We want to link it, so we did this last week. Find a point. Just make sure it's in the right location. Right click, set 1 point, and we can link this to center point. And you can see how it's moved. Okay? Because this is my site, I want it to be around my site. This is related to scale, right? So 1 means the same scale, 2 means double the size. So if you do this, it gets bigger. Okay? This is 1, this is 2, 3. You can make it as big as you want. Okay? So what you need to do is hover over each input. So we know which ones are the necessary ones, but in order to understand what the input does, you can hover over and it'll tell you. Okay. Okay. So now we need another node called analysis period. Okay. So if you hover over this one called HOIS, which means hour of year, so the data set we imported, the EPW, is structured where for every hour in the year we have a reading of different things. Okay? So for every hour of the year we have a reading of temperature. For every hour of the year we have a reading of radiation. For every hour of the year we have a reading of wind speeds. Okay? So instead of analyzing for every hour of the year, I want to select a certain period, right, for this exercise, because otherwise the script is going to be very heavy. So one tip, very important to mention now, because of how flexible Ladybug is, it's very complicated. Yeah? And if you don't control from the beginning, it's definitely going to crash. So make sure you're saving corrupts, okay? I'll show you some of the mechanisms they embed to prevent it crashing, but make sure you're saving as we go, because otherwise you'll lose it. Okay. So, hour of the year, we can filter it using this one called analysis period. Okay. So analysis period, as is indicated in the name, is a period. Yeah. So if let's say we want to analyze from March, so start month is March, which is 3. And you realize it's already gray, right? So it's already running. So if I have a panel here, I want to show you quickly. It says 1/1 to 12/31. Okay? So from 1st of January to the 31st of December. This is our analysis period, right? But once we start changing it here, we can say start from March. You can see it's saying March 1. Yeah? So this is where we're defining which period we want the analysis to work with. Because, for example, in the winter, you might say that sunlight isn't as significant based on the angle of the sun, or if you're doing radiation, there's no direct radiation in the winter as in the summer. Okay, so there has to be a rationale behind it as well. Start day, if we hover over, we can see it's 1, so this is the first day of the month, that's fine. Start hour, 3 o'clock at night really doesn't matter to me, so maybe I'm gonna start at 9 a.m. as a start hour. End month, let's say September. End day, doesn't matter. End hour, let's say 7 p.m. Okay? So 7 p.m. will be 19. So now we can see as a period, it says 1st of March to the 30th of September between 9 and 7 p.m. Okay? So you see, it's a very simple filter thing. Yeah? And if you go on HOIS, if you connect this to HOIS, this is actually giving us the hour in terms of its order in the year, right? So it's starting off from the 1425th hour, right? So, but I think the period, this is more intuitive, right? This doesn't matter, but we know the outputs are the same, so we can connect HOIS to HOIS here, okay? And you'll see something turn up, you'll see this change, right? So they're big nodes, so you have to. Does anyone know what the new what this is? Yeah. Exactly. So because we defined the period, it's actually giving us the location of the sun in every point. So for every hour we selected, it's actually plotting the game. Okay? The top of this is the longest day of the year, right? So in the summer, the lowest part is in December when the sun is lowest in the winter, right? So this is the range in terms of the season. This is the range in terms of hour of the day, right? So we set from 9 to 7. So this is 9 all the way to 7. Or this is 9 all the way to 7. this is every hour. That's why you see a gap in between. Okay? And this is the season. Okay? So yeah, these are points. So they're actually geometries in Grasshopper. And this shows you the range across the year, right? Over different periods. So let's do a quick exercise here. So let's do line. You don't have to follow this, by the way. But let's say I want to connect this, and conveniently I have sun points, right? So these are the outcomes. So I can see for every hour of the year we selected, I can actually have the exact vector and line going into my sites, right? So again, the sun projects it in parallel, but this is diagrammatic, so it's showing it based on the time, right? Yeah. So if you go back here and say, I actually just want March, the whole thing changes. You see? So this is in March. So you see the month of March changes, the angle changes a bit, and this is from 97. So we can always go back to the analysis period and change it. Any questions? Sorry? The line is not important. I just want to show you how you can use geometries, right? So it's actually showing you where the direction of the sun is. It's not just showing you where it is on the diagram. Yeah? So you have sun points. So this is the point on the diagram. And you have our original points. So how we're controlling we can use the same points. Yeah? But we don't need this, by the way, so just delete it. I just want to illustrate. Okay. So I want to go back and change this to, I'll do June for now. Okay? So let's say these are the most important hours I want to use. Okay. So you can see already how the data is helping us understand the site better. Yeah? Okay. So we mentioned we want to get to the direct sun hours. So let's just create a mass in Rhino. Okay, so I want you just to create a mass the size of your site, however it is. Okay, just like this. You should all follow. You want to cap this cap, and I want you to bring it in Rhino, in Grasshopper. So right-click, set one brep. Okay.
Why using brep
Instead of geometry?
Yeah.
Brep is better to work with because geometry might interpret it as surfaces, but brep is boundary representation, so it treats it as a volume. Yeah. So you want to have a poly surface here on the top, and then link it as a brep. So right-click, set one brep. Okay. So at the moment it's not connecting to anything else, just this. Making sense? So sometimes it's better for you to create it in Rhino. Because Rhino, you can control it easier, so you can move something. If you want to iterate something manually, it's better to create it in Rhino. In Grasshopper, you have to develop the relationship. So where is the position in space? But for our exercise, we don't need to do it. Now I want you to get this node up called contour. Yeah? Contour. Yes. I'm going to give you 2 minutes to have a look and tell me, try to use it. Tell me how to use it. Okay? Contour. So we go now? Yeah. Sorry? Contour is the box with the red lines across it. Yeah, this one? Yeah, this one. So it's the one to work with rep or mesh. We don't want the one working with curves or surfaces. Rep or mesh, because that's what we have here, rep. So what does contour do? Create a set of prep or mesh contours. What's a contour? What's a contour? Yeah, slicing. Yeah, exactly. An outline of a profile based on a volume. Yeah. So straightforward. We have a shape. We have a point. We have a direction and we have a distance. Okay. So the direction is we want to create floor plates or something resembling floor plates. So the direction is Z, up. Okay. So we want unit Z. So unit Z gives us a unit vector, which is 0, 0, 1, telling us up. Okay. If you were if you were here last week, you would have, you know. Fine. If it's already set, you don't need it. But so if you hover over, it says already 0, 0, 1. You're right. Yeah. But just to be obvious. Distance. So distance between the contours, right? So I don't know, anything between 3,000, 3,500 for now. These are rough, right? So I don't. So the point of this exercise is not to automate the design of a building. The point of this exercise is to give us some information and geometry to build on the design of a building, right? So when we're saying 3,500, it's basically a way for us to segment rather than saying these are floor plates. And I just want to hide this for now, so I'm going to do preview off. I'm going to go on wireframe to make things look a bit. I want to turn this off, by the way. So go here and preview off. Okay. So what you should have now is this, which is my breadth in Rhino divided every 3,000 meters. Okay. I can always go back and change this, right? So this rep is referenced. So if I change the shape here, everything gets updated. Yeah, that's the whole point of using Grasshopper. So, okay. We can use a surface container to change these into surfaces over here. Okay. Okay. So now it's very straightforward, right? We took a brep, which is a volume. We divided it in the Z direction every 3,000 meters. So that's here. And basically we get surfaces out of it now, right? So these are all I have 6 surfaces coming out. Yeah. Yeah. I want you to right-click, flatten over here. Okay. Basically, it's giving us a very different data format, and I just want to make it in one list. Okay. You can have a look at it later on. Okay. Right. So, to work with this analysis, right, with this node, it tells you what it does, right? So if you hover over, it tells you calculate the number of hours of direct sunlight received by geometry using sun vectors. Okay. So now what do we use? We use the sun path to generate sun vectors. So we have the vectors, and what we want to figure out is hours of direct sunlight. Okay. Received by geometry. And now we have the geometry, right? So if you're working with a very basic geometry for now, which is the floor planes, yeah, I can link those to the geometry. Yeah. So these go here to geometry. It's turning red because I need this, remember? Underscore on the left. If I go over here, it tells me I need the vectors first thing, right? So if I go back to the sun path diagram, I have all the vectors here, right? So vector means where the sun is directed at different hours of the year. So I can link that here, okay? Sorry, this is geometry, not timestamp here. Yeah. Geometry. Okay, so orange is better than red. Yeah.
Do you all have surfaces?
Yeah. You all have contours and surfaces? I think did you save it?
Yeah, but like.
It crashes a lot. Okay, so two more inputs are required here, right? Grid size and parameter run. Okay. So what do these two do, right? So if we go on grid size, this is probably the most important input parameter because this has caused me the most issues, right? Because this one I'm controlling the resolution of the analysis. Okay. So if I have a very high resolution, it's going to take a lot of time for it to process because it's very complicated mathematics. So the best thing to do is start with a very low resolution, okay? And then we can increase it. So grid size is the size of the, if you take a surface, so it's the size of the cell I want to analyze over here. So it takes a surface and it divides it. So if I give it 1,000, it will divide the surface into 1,000. Like we did 1,000. If I give it 10,000, it will divide it based on 10,000. Okay? Every surface, yeah. So I want to start off with a high number. So the bigger the size, the better to start off with, right? So 10,000 is my grid size for now. Okay? No. So it's grid size, not number of divisions. Okay? Number of divisions is different to grid size. Grid size is in your Rhino units. So my unit is millimeters. I'm telling it to divide the surfaces into things resembling roughly 10 meters by 10 meters. Yeah?
Can I ask a question regarding like probably why do we flatten the surface? And then we connect
because it created a list data tree. You don't need a data tree.
It's already flattened in the geometry.
Yeah, so there's no need. You don't need.
Okay.
So this is already there as a precaution because they know it needs to be flattened.
Okay.
I forgot about this. So you don't need to flatten it. You can't flatten the flattened thing already, so it doesn't change anything. Good. Offset distance, we don't need to deal with this. Legend, we don't need to do this. Okay, so the last one we have is the run input. Okay, so if we hover over, it says set to true. It says set to true to run the component and perform direct sunlight analysis. So this is how they designed the plugin in Ladybug, for it not to run except when you tell it to. Okay? We already have a case of someone crashing the computer over there. That's the point, right? So make sure you're saving it. So this is one of the mechanisms, right? So whenever you're building the script, you shouldn't have it as a run, but whenever you want to run it, actually, it's better to have this one here, by the way. It's called button. Okay, button. You click it, turns true, and then turns false straight away. You don't have to. Doesn't matter. Let me go back to this one. Okay. Okay. So once I connect this, you see it's orange, which means it hasn't run. Once I connect this, it's going to run. Right. And there you are. Our very sophisticated building has been analyzed in terms of ours, right? Some of you are going to get a completely blue building. Okay? Does anyone know? We talked about this last week. So some of you will get all of the panels turned blue. How many have got all of the blue? 1, 2. Only 2? Should be more than 2. No? Does anyone know why? Huh? So surfaces have an analyzable edge and a none, right? They have a front and a back. So when you have blue, it's flipped. So basically, you can't analyze the front edge. That's where they analyze. So you need to flip it. Okay. So if you have a blue surface, it means your surface is upside down. So what you have to do is go on flip, and I'm going to show you how it turns blue, right? This is what you all have. Okay. Yeah? So this is wrong because the surface is upside down. Yeah? So you flip it if it's like this. Wait. But this is the right one to have here. This one, okay? Okay. So we can see it's quite obvious, right? All of this gets around 1,293 hours of sunlight based on our period, right? So the unit corresponds to hours of sunlight. And we can see some of these areas. So these are roughly 10 meters over here. Okay. This is the cell. This area is getting around 669 hours. Yeah. So we can easily interpret the results. Yeah. Okay. There's one more very important thing here, which is called context. Yeah. So this relates to the question you asked, Jake. This context input relates to the question you asked about whether the environment has an impact on the analysis, right? At the moment, we're assuming the building is basically floating and there's nothing around it, right? It's perfect. All the sunlight is hitting it. That's not the case. Usually we have some context. I mean, this site isn't the best to describe because, you know, it's actually quite, there's nothing disturbing the sunlight, right? So what we're going to do is we're going to create an artificial building just to demonstrate. So here, if I go in Rhino again, just create a building, let's say this height. I want to bring it in here, brep. One brep. Okay, I'll come in a bit. So if you create, and this is a good tip, right? So if you're working with real context in a model like this, don't use this context. Just use very basic blocks. Okay? Because this is very computationally expensive. You don't want to calculate whether this window has an impact on this. Doesn't matter. Yeah.
Might be a little bit silly question.
Yep.
Does it calculate bounce, what they call like bouncing rates? Basically, does it take it into consideration as like shadow, or does it calculate it where
So
light bounces back?
no bouncing back. So this is direct sun hours. Right. There's other stuff for bounce back, right? So this is exposure based on the cell division of that surface to sunlight. So if I have context, so this is my context. If I move this here, you'll start seeing that, okay, my context is actually inside the building, which doesn't make sense, but it's interfering with the sunlight analysis. You see here? Yeah? So let's move it outside. Let's pretend it's a building that's right behind. So if I go here, let's say the building's here, okay? It's actually a tall building. It's interfering with my light analysis, right? Okay. So this is what you use for context. So your geometry is what you're analyzing. The geometry affects itself, right? So this gets all the sunlight. This doesn't because it's restricted. But context affects the geometry from the outside. Someone was going to ask me a question. I forgot who. Sorry, over here. It's recorded. Okay, so you can see the outcome here, right? So points. So we have 210 points. These points correspond to each segment, right? So based on the surfaces we gave it segmented them into 210 segments, and for every segment we have a reading here as well. Okay? So you can actually get this specific reading with physics based on the axis of the list. Okay? So it's actually giving you data that is very useful. The outcome is a mesh. So you gave it NURB surfaces. It gives you a mesh as an outcome. So if I was to bring this here, link this here, bake, okay. Click on this. This is my mesh. bring it here, and then go on shaded. This is actually Rhino geometry, right? And it's a mesh, which means it's a different type of geometry, but it's already embeds the colors in. So you can actually say this geometry. It doesn't have to exist. It looks very neat because it's a very flat and unique surface. But once you work with something more complicated, it gets a bit messy. You have too high of a resolution. It's going to crash. You need to increase your grid size. Okay. Right, so now I'm going to delete this. We don't need this anymore. I'm going to go back here. So now it's obvious that we're working with direct sunlight. Right? So how do we manipulate this object to let in more sunlight and explore how to let in more sunlight?
Galapagos.
Yes, but Galapagos can't change something behind it. We didn't change.
We can feed it with Galapagos.
Yeah, but how do we control voids here? How do we start picking it apart? How do we start letting in more light into the building? What do we do? How do we change the form?
Change the form where there is more sunlight already.
Huh?
We change it for
Yeah. So I mean, I can do it manually, right? So I can go here, explode, and then pawn, and then let's say I want my building to do this, and now I go back here, like this. Nope, I don't want this.
And we're about to create a loop.
Let's say I do this, and then I do join, and now I have poly surface, and now I go back here, set one brep. Can do this, right? So what I'm doing is I'm manipulating the brep. But imagine that I have to go back and design massing the ball every single time, right? So the trick is we want to embed something in Grasshopper that we can change very quickly to update this. Right? This is what we're analyzing pretty much. Right? We're taking this volume, we're dividing it, and then we're telling it to analyze it. Right? So what we want to do is work with Booleans. Again, similar to what we did the other week. So work with the geometry, stop putting holes in it, that we can move in Grasshopper. Feeding into here, and then seeing the output. So we don't want to do it manually. That's the whole point, right? You can use it as a tool to give you information as you design something. That's fine. That's also valid, right? But for us, we want to kind of work with this, right? So this is our analysis at the moment. I'm going to turn this off because we don't need it. Because every time I'm going to change something, it's going to update, right? So I'm going to move this all the way over here, okay? And now here's where I'm going to start putting in some of these voids that I can start exploring with, okay? So I want you to just have 5 objects as voids, okay? So make them a Rhino, and then reference them here. 5 objects. As breps. Yeah. So make them into poly surfaces in Rhino, import them here as breps, and then I want to start to basically poke holes in it using the voids, right? So have something that maybe resembles a light well, have something that maybe resembles a horizontal space, have something that maybe resembles an entrance, something that maybe resembles a courtyard, yeah. That has voids. Okay?
And they're going to move around.
Exactly. So in Grasshopper, we want to control their position. And then we can change their position based on Galapagos scores. Okay? Is it working? No? Well, can you send him your file?
Yeah.
I'm just making it.
Okay. So
I'm going to put it in the group. CPU March.
Okay, so this is where you should be, right? So I have my original box. I have this item, this item, this item, this item. And I'm using a solid difference. So I'm subtracting this volume from these four, and then I get something out of this, right? So if I bake this, I just want to show you. This is not our final thing, but something to show, right? So you'll end up with something that looks like this, maybe. Okay? It all depends on what the holes you're putting in. Okay? So your main volume over here, your main volume minus all these other volumes, you'll get something like this, right? A mass. Okay? Yeah, so what you have there is good. You want more time to do it, or? Okay, so the main one, subtract the other. Yeah? Or you can, this is fine. Yes, of course. How do you do the difference? Tell him. Ollie, sorry to be a pain. Can you send him this book?
Yeah, they have like
I do.
use mine by hi.
So these are all, these are things you do intentional, right? So at the moment, we're doing them a bit random. But when you're designing a building, you have to do them intentionally, right? So if you're designing an atrium, can't be a donut, right? You want to design it in a certain way. So solid difference is when you subtract, but you can also add, right? So you can, let's say we want to have a tower located somewhere. So we want to have a tower located somewhere. So let's say here, right? So we can have this brep here, set one brep, and we can do solid union, for example, right? So solid union will add our massing to the other massing. So add here, right? And now I have a completely, So it might be a way for me to explore voids or explore where to position certain volumes as well, right? So it doesn't have to be just voids. Okay, so let's carry on, otherwise we're gonna struggle for time. So we have this, right? So how do we, in order for us to, is everyone listening? In order for us to explore where to position these voids, basically we want a slider to control their position, right? So what we'll do is we'll bring in move, and we'll create an X and Y direction for us to move.
Then when it is out, that's going to create a surface instead of making a
No, it's a volume. It's a volume.
Yeah.
So the volume. It's going to create a curve for the solid part.
with the
I think I know. Yeah, I think I know what you're saying. Okay, so in that case, I think you're right. So let's do. Yeah, I have to think about that. I'm gonna.
multiple levels.
Okay, I didn't foresee that. So I'll carry on with this, and then we'll figure that out. For now, we'll just ask him to make something basic, more basic. Yeah. So we want to bring in move, as I said. So move. So let's say I want to explore the position of this tower, okay? So I link this to geometry. I want to create a vector, remember, so we use vectors to move things. Z is not important. I don't want to move this up or down. I just want to move it in the X and Y plane. So I can say here, I want a slider, number slider, connect this. And here I need to be careful with setting the ranges. So if I want my tower to move maximum this way, and I know that's 102, right? So I can go here, go on number. My minimum is minus 10, 1, 2, 3. And my maximum can be 50, 1, 2, 3, right? So, and if I link this here, so my slider allows this range, right? So you can see 5,000 is too much here. I can go back. I'll change this to 3,500. Sorry. 35, 1, 2, 3. 35 meters. Yeah. So I need to make sure my ranges are defined based on where I want it to be positioned, right? I can't position it further down the model. It doesn't matter to me. Yeah. So setting these ranges are very important. Yeah. Same thing for the Y. So for the Y, so this is minus 10,000. I think that's fine. And maybe I don't want my tower to go beyond this point, right? So you see, I've limited it to this edge all the way up to this edge. Okay. And these are the sliders we want to explore later on, right? As parameters. Okay? Yeah. Yeah. So it's based on your own design decisions, right? So what do you really want to control in this one? Some of you might just have one courtyard that you want to explore right to position, right? Or certain openings. Doesn't have to be. You don't have to do everything in a row. I want to do the same for the rest. So I'm gonna move this here. So this is for one item. Copy and paste. Literally the same script. Rep. Then I can already see this is too far, right? So I can set my. Actually, I don't want to move this in the X. I just want to move this in the Y. Okay. So for me, I might go minus 35, 1, 2, 3, and just 1,000 here, 1,000 there, right? So I'm setting the boundaries of where I want it to move. I don't want it to be anywhere outside this range, okay? And I just need the Y here, right? I don't want the X, for example, okay? Sorry? Yeah. Because our slider goes from minus to positive. So a minus vector will move towards the left, a positive vector will move towards the right. Right? So it's like an X and Y. So plus 1 moves it to the right, minus 1 moves it to the left. Yeah? Because it already has a position here, right? So if I go back onto Rhino, so this one, and change its position, my range is going to be messed up now. See? Because it's based on the original position. Yeah, it can be. So these numbers, I'm just defining, just eyeballing them now, right? But you can choose which position. Okay. So some of these voids I can move X, Y. Some of them I just need to move Y. Some of them I just want to rotate, for example. Yeah. So this one I don't want to move at all, actually. I'm just going to leave it here. Okay. This one I want to start moving, so let me bring this down. I want to create copies of this. Link this here. That's okay. I want this to move in the Y as well. So I go here. That's Y. That's a bit too much. Maybe that's fine. Minus. I'm gonna confuse them out now with
Feeding it to.
yeah. It's okay. They need to get it. So for my so I have my volume, right? And I have this object as some kind of courtyard to let in light, or atrium. Okay. So for me, this is a very important part. I want to change its position in X, Y, but I'm also exploring voltage. So maybe this angle might be the best way to let it light, or this angle. So it's something else I'm adding here, right? So I've moved it, so I've set the parameters in terms of minus, maximum, and minimum here. But now I'm actually controlling how I want to rotate it, right? So here, I can rotate it.
How does the motion component call?
How does what, sorry?
How is the motion component called? Because I'm trying to search it.
Motion, move.
I just moved.
This is move. This is vector xy. Okay. So again, it's getting messy, right? You need to be organized with your code. This is not a good example of how to be organized. Right? Okay. So let me group these. So this is one. This is another one. This is another volume. Radians. Control G. So you select a group and then Control G. Okay, so now here at least I can see straight away where my objects are, right? There, here. Okay. You can't ungroup. Oh, you can move it in like this, but it's not within the group. So you have to ungroup and group again. Yes. Yeah. So Galapagos literally just plays with the sliders. If it's min max, yeah. So that's why you see it's important to set the ranges. Yeah. Right. So now, what I basically need to do is get rid of all the original ones and add the new ones, right? Because that's what matters to us. Because now the new ones, they have a position, a way for me to control position, right? So you can see here, if I go back and change something, the whole thing changes. Yeah. So I need to get rid of all the original breps connected to this one and connect all the new ones which are controlled by the position, right? So this is still my brep, the basic one, goes into A, and the B ones are all the new ones. Yeah.
So for you, it's not creating double surfaces.
No, it's just one volume.
Because everyone is creating double surfaces.
No, I'm not sure.
Because then, what do you do when you get contours?
So okay, so now let's check. It works fine. It works fine for me. It might be the way you built the Rhino geometry. So you either have them as surfaces or you have it as an open text to go to solid view. So I'm going to bring it all the way down to the contour. Okay, so all my negatives, all my voids connect to here, ultimately. Okay. So you don't have to have 4 for now. You can just start with 2 and then build it later. So this is my original box. This is whatever I'm subtracting from. Okay? And I can add stuff here. You don't have to do this.
So for now, make this.
So for those of you who've managed to subtract a volume from a volume, try to go back here and run the analysis. True. Oh gosh. Okay, what is going on? You know what? I'm gonna get rid of
Reason why, like in their case, is not cutting through. It's taking the outline to create another surface.
another
Yeah,
surface.
same in there. Same in there. Looks like. What
Okay.
if we do intersection between
Yeah.
planes, XY planes that are repeated and solid?
So there's a bit of a glitch here. This didn't happen to me yesterday, but you can see there's an issue with the surfaces here, right? Have some of you? Do you have this problem? Yeah. Okay. So let's solve this in a different way. So if we take this, we're gonna try to. Okay. If you go back to your original BREP, this one, and then and then get the contour command here, shape, direction, unit Z. Unit Z.
Are we doing the same thing?
Yeah, there's a bit of an issue. So you see here, my geometry is a bit confused. See? So there's something wrong with the contour. I think that's because here at some point it's creating a surface. It's creating two overlaying surfaces. Okay. So what I want to do instead is bring this, create surfaces. Okay, and I want to. I need to find the right one here. So split with BREP, solid. Let's try solid. Different surfaces here. Flatten. Surfaces here. So just give me a second. I need to figure this out.
Mine actually became fine after I switched contours and surface off.
What
switched
you did, sorry?
previews. So I just turned preview for this one and now off. And now it's looking like that. So it was like initial geometry. Like
Yeah,
before.
but mine is still not working. It's working now.
Yeah.
Oh, it's working now. Let me see if I move it. Is that? Yeah, it works. It's a weird glitch. Okay, so by the way, so this actually works. Okay. What I suggest is, I think Ollie pointed out, maybe it's a glitch or something, but I suggest turning preview off for everything else, right? If you have a solid volume here that you contour, right? You should get this as an outcome. Okay. So make sure your object is not an open wrap, it's closed wrap. So the way you do it actually is open. So where do you have the Okay. So we have everything set up. I appreciate some of you are still figuring out, but I wanna run this, and then I can go around and have a look because it's gonna be a bit slow running, okay? Because it's a heavy model. So if you get up Galapagos, Galapagos is a native plugin to Grasshopper. Everyone has this already installed. But if you go on Tweet for Rhino, you'll find new plugins for newer evolutionary algorithms, right? Which perform better. So you can have a look at evolutionary algorithms more later on. Yeah? But Galapagos works very well for what we're going to do now. So, so we have the results over here. This is my hours of sunlight per cell that I'm analyzing. Okay? So I can add all these up to get my number of hours for my mass. Okay? So my job, what we want to do here is to maximize the number of hours based on the mass. Okay? So I can do something called mass addition. Sorry, mass addition. Mass addition to add everything up. So I have a result here. My fitness score, so this is what I want to maximize. I connect it to results. Okay. Results go into the input of mass addition, which gives me results, which I need to connect to the fitness score in Galapagos. So in Galapagos, it works opposite to the other ones. It likes to feel special. So you go from fitness, you go from there downwards rather than from left to right. Okay. The genome is whatever I can change, or whatever I want to change for this, right? So I want to change the position of this mass based on y, this one based on x and y. I want to also rotate this mass. I want to connect all these sliders. Now I'm being a bit ambitious with the number of sliders, right? Because it usually works well with 6 sliders. Anything more becomes a bit problematic. Okay, so. Yeah, so fitness you want to drag down? From fitness, yeah. And then from genome you want to drag out as well, okay? Click, it works now. No issues. I think it's just a visual glitch.
It's creating multiple surfaces. When there is a curve inside another curve, that curve is going to create another surface.
So is your break closed? It shouldn't do if it's closed. We'll have a look, yeah. Okay, so yeah. Okay, so at the moment it's not doing anything, right? So you want to double click on the node. So this again is a node that works differently from the other ones. Okay. You get this interface. Over here is very basically and crudely, right? You can explore it in your own time. But here is asking you whether you want to minimize or maximize. I want to maximize the number of sun hours. So the higher the number, the better. I go on solver. This one starts. This one, so if I click on the left, it will show all the iterations live as it iterates them, which is very heavy. Okay, so I don't suggest you do this, but I'm gonna do it to show you guys, right? So, so if I click on start solver, you should see it randomly change the sliders to start off with. Okay. A lot of this geometry doesn't make sense as a building. You can post-rationalize later, but it's giving you something to work with. Yeah. So realize this is very heavy, right? So every iteration is taking around a second and a half for each iteration, right? If we have a lighter script, it will be faster. So for every iteration, changing the position of the voids, subtracting the voids, doing the analysis, and then displaying it, right? So it's quite heavy as a script. So that's why it's slow. That's why it won't come up with anything here yet, right? But if you give it 5 minutes, it will. If you leave it running overnight, it will do the whole thing for you. Yeah?
You don't have to see it.
It's a display. Turn off the preview for everything else.
No, but I mean, it's not that it's not preview, so you check the distance.
No, it's changing the beginning, it starts randomly. Yeah. So
your slider is from 0 to 5,000. Is it increasing parameter?
So here, Yeah, so you can see here, right? So it starts off random, right? So basically it doesn't understand it. So it doesn't know which works best. It starts random. Then once it finds something, so once it finds, for example, that certain mutation works, so it iterates within like that. So so this is the first groups. Yes. So you'll find it usually goes this upwards. So upwards indicating the range. And then you'll find there's a certain band here that it works with, right? So these are all the iterations explored now. The ones that are X are the worst ones. It doesn't want to use those limits anymore. So you'll see now, it's actually staying here. Yes. Yeah. Once in a while, we'll jump in case it is something like this. So you have to click on. Is it running? So it's doing everything in the background, but it might crash. Click on this one here. This here. It says display all genomes. Right? Your script might be heavier than mine, so it might take longer for it to do it. Sometimes it'll take 5 minutes to generate one iteration. That's about it. How to kill it? Kill it by clicking on this. So your computer is killed. So, Jake, you can start seeing it here, right? So each one of these is the range of a slider over here. Okay. So if you count the sliders, we have I think 8 or 7. 1, 2, 3, 4, 5, 6, 7. 7 sliders. And it's basically saying these ranges are working best, right? So each line indicates one iteration, showing you the range. But slowly this band will get smaller as it figures out which iterations work better. Right? And you can already see it. Initially it started off a bit random, but it's saying that the courtyard position here will let in more lights. So it's kind of slowly learning. It's self-reinforcing. It's called machine learning.
How long? So you said that can run all night.
Yes. So it's based on the settings. So you can tell it to for each. So there's runs. So for each run, I want you to do 50 iterations. I'll do 50 runs. Right? It's based on the initial settings on the option.
And it depends on the resolution we have to write, or does that differ?
So here, you can give it a max duration. But if it's already converged, then you don't have to run it. It's already reached some. So, does anyone have any questions about this? Okay, I want to wrap this up. So if you have any questions about, not specifically about your script, but generally about what we did today, then you can ask. Yep.
Yeah, so my question is just whether, if I understand it right now,
Yeah.
the thing which is then solved at the end is going to give us a layout which gives us much light.
Yes. Based on our limits, right? Based on where to position this. Because it maximizes. So the highest number of hours. Any more questions? So, okay. So I just stopped this now, right? So what you get at the end is this this graph, right? So telling you where, so if this is the minimum and maximum range for each slider, right? It's telling you where the line is finding to be the most efficient. Okay? So this is a graph representation of the space, design space. This here is each iteration, right? So we have 7 sliders, 1, 2, 3, 4, 5, 6, 7. So these lines correspond to each slider. The size of it corresponds to the range. Okay, so you can start seeing, this is the score here. So this is the best one we have. Okay, 753,000 light hours. Okay, and if we reinstate, yeah, so reinstating it brings the geometry here, right? So I can go back to the least performing one there, reinstating it, and this is the least performing, right? So there's actually not much difference, yeah, because this is this last generation, right? So if we select this, the previous generation, there'll be a bigger difference here, right? So see this is the best one. If we go all the way down, this is the worst one, right? So it's actually interactive, right? It's not just visual. You can start selecting. So basically, these are all the iterations it did, and this is their ranges, right? And then if you select all the iterations, you can go from the worst here, which is this, to the best. But the best isn't always the best, based on your values as a designer, right? So you have to engage with whatever it gives you. So you might say this doesn't make sense in terms of a design intervention, but one lower down, like this might make more sense, right? Just because it gives me an access and I can play with here. Yeah? How do you bake them all?
Yeah.
Good.
Not
See,
all of them.
I predicted your question.
Or,
Okay, so I'm gonna show you something else. So I wasn't planning on showing this, but if you type in record, this is called a data recorder. So every time the data changes, it saves the previous one. Data recorder, yeah. So the most important things for me are the result, right, and the geometry there. So at the moment I only have one item, right? So whatever I'm giving it, the result is giving me out, right? But if I change this, so if I go back here, say I want this to be 0, enter. The analysis is changed, right? Because I changed the position, but it saves the previous one.
yeah. Is there any clever way of combining two lists together? Because,
Yeah.
like, yeah.
So now I have 2 items because I changed the previous one, right? So it's recorded the previous iteration, and this one is recorded. So here you want to group, by the way. Eh? So group your geometries here, because otherwise you have a big list. So I'm gonna restart this. So this is how you restart. Just click on the X here, cleans it. Right, so it has nothing in there, and now I want to change this to minus 10,000, right? So now it's saving that iteration, right? So this is, okay. So this is already recorded. So when I go back and change the slider, here, 0 or 9, yeah? So it's recorded the previous iteration. So if I link this, to Ladybug, right? I just want to do this quickly, but you should be able to see. Come on. There we are, saving them all here, right? So once I finished, you can see geometry number 26, number 27. So each one of these is saved. So then you can create a grid and you can outline them all and just distribute them based on sizes. You have a big grid.
What is it?
To visualize it.
To RAM or to your hard drive?
So at the moment it's not saved to the hard drive. It's saved. Okay, so I'll show you again. So here, it's a Grasshopper data, right? So here, if I disconnect it, I'm gonna lose everything, right?
Yeah.
So one way of saving, I know these are geometries, so I can go brep, right here. I can actually save as group here, group there. If I right click, I can't internalize. Just give me a second. So I can do this, right? So this is a lunchbox plugin. Basically, I can create a file directory and save them all. Okay? So but I can actually link this directly to the save. So whenever it changes, I can save it automatically. Okay?
Yeah.
Or, let's see if this works. Or I can do something called internalized data. Okay? So internalized data, you see the link is gone. So basically what I told it, I linked it, I give it the data, and then once I internalize, it just saves it within the node. Okay? So if I want to save it within a Grasshopper, I can save this, and I'll always have this inside. I'll always have this data inside. Right? If I want to save it as Rhino geometry, I can use this as a lunchbox tool. Okay? Does that make sense? Does that answer your question? So this is the same structure, then each index with the item corresponds to each index with the object.
Yeah, and the numbers, they match the numbers in the solver. Right?
Yes, they match the numbers in the solver, exactly.
Is there a way of getting your, without having to look through the numbers,
Yeah.
solver and your list,
Yeah.
get it to just repeat it, that's not just
Select the
just make the best one, or just
Yeah. So again, so it's a list, right? So we have a list of numbers, we have a list of items. We can do something called sort list, right? So sort list. So these are the values, these are the keys. So see, it's sorting them from best to worst here. And I can use the way it sorted these to sort these, right? So now I've sorted my numbers, but based on that shuffle, it's doing the exact same shuffle for this values. So my geometries here are actually now listed based on best to worst. So I'm sorting the numbers, and based on that order, it's applying the same order to this one. So once it becomes a list, I can easily manipulate. Right? So I can use this to, for example, sort them if I want to create a grid or a matrix of all the iterations based on worst to best. I can create a grid and then sort them all using the Okay? So you can save it in different ways, you can manipulate it in different ways. That's the whole point of Grasshopper. You can do whatever, but you just have to figure it out.
and then you can just make like the first 10 on the list.
Yeah. Best 10, or you can even do a 10 by 10 grid. You can make all 100. You can do it automatically here, right? You just have to put the nodes as a grid. Yeah. So first item is the highest score, second item is the second highest, third.
You basically need just a
Yeah. Any more questions about what we did today? No? Okay. Good. So now you're all, I would say, nearly experts in Grasshopper. Okay. So you don't need my help anymore. You know everything, of course. You know how to download the plugin. You know how to use the plugin. You know how to work with lists, save data. You know how to manipulate geometries. Especially the CPU master students, I showed you a different way of doing it last week, right? So I want you to think about your own diagrams and how you can embed them in this computational process. Okay? But yeah, you should all know how to build scripts now. As long as you have a good idea, you have a good idea.
Why we get to feel like we're just done with that?
Sorry?
We're done with that.
I'm not done with you, so I'm all here.
All your experts, right?
I said nearly experts. Nearly, right? Cool. Right. I'm gonna go around and see if you have individual questions. Okay.